triangle SAM, S-A-M, and this is this one over here, S-A-M, is rotated 270 degrees about the point 4 comma negative 2. So this is 4 comma negative 2 right over here. Draw the image of this rotation using the interactive graph. And we have this little interactive graph tool where we can draw points, or if we want to put them in the trash, we can put them there. The direction of rotation by a positive angle is counterclockwise. So this would be 270 degrees in the counterclockwise direction. So to help us think about that, I've copy and pasted this on my scratch pad, and we can draw through it. And the first thing that we might want to think about is if you rotate, and I've talked about this in the previous video when we were rotating around the origin. If you rotate something by, last time we talked about a negative 270 degree rotation, but if we're talking about a 270 degree rotation, if you imagine a point right over here, this would be 90 degrees, 180, and then that is 270 degrees. That is a 270 degree rotation. We're going in a counterclockwise direction. You see that that is equivalent to a 90 degrees clockwise rotation, or a negative 90 degree rotation. And 90 degree rotations are a little bit easier to think about. So let's just, instead of thinking of this in terms of rotating 270 degrees in the positive direction, in the counterclockwise direction, let's think about this, rotating this is 90 degrees in the clockwise direction. They are going to be equivalent. But how do we do that? Well, like we've done in previous videos, what I'm going to do is I'm going to take each point, let's say point, using a color you can see, point M, I'm having trouble switching color, point M right over here, and I'm going to construct a right triangle between point M and our center of rotation, where the hypotenuse of the right triangle is going to be the line that connects these two. So let me draw that. So that's the hypotenuse, and let me draw a right triangle like this. So it's going to go, it's going to be like, it's going to look like that. And then it's going to look like, whoops, that wasn't, I have to press the command button before. Okay, there you go. All right, so I have this right triangle. So if you imagine rotating this right triangle, this magenta one that I just constructed, by negative 90 degrees, or 90 degrees in the clockwise direction. Well, what's going to happen to each of these sides? Well, this side, right over here, if I rotate it by negative 90 degrees, it is going to end up pointing up. And how long is it going to be? Well, let's see, this one is 1, 2, 3, 4, 5, 6, 7 units long. So it's still going to be 7 units long. 1, 2, 3, 4, 5, 6, 7. It's going to put us right over here. It is going to put us right over there. And then this side, let me make this clear. This side that I'm highlighting in green, which we see is 4 units long, it forms a right angle. It forms a right angle. So if you were to rotate the entire triangle 90 degrees in the clockwise direction, well, then this is going to go 4 in this direction, just like that, just like that. And then your new triangle, the image of, I guess, what we just, this right triangle I've constructed, if I rotate it by negative 90 degrees in the clockwise direction, is going to look like this. So after rotation, so what did I just do? I just took this triangle that I constructed, and I rotated it negative 90 degrees to get to this triangle right over here. And so the point M, its image after the 90 degree rotation would be right over here. And I could call that, I'll call that M prime. And what I'm essentially going to do, I'm going to do that for point M, I'm going to do that for point A, and I'm going to do that for point S. And I'm going to connect the three, the M prime, the A prime, and the S prime. And then that will give me the image, that'll give me the vertices of my new triangle, the image of triangle SAM after rotation. So let's keep going. Let's do this now with point A. With point A, and I can construct another right triangle, and I could do it several ways. Actually, well, let me just do it this way. Let me draw it. I could draw this. The hypotenuse we know is going to go from here from point A to our center of origin, and I could draw a right triangle that's up here like this, or I could draw a right triangle that is down here like this. Maybe I'll focus on this one. Let me draw this right triangle. So this right triangle right like this. So if I draw this right triangle like this, so this side, let me do this in a color that I can see more clearly, or that is, let's see, this side, no, you won't be able to see that. All right, I'm going to stick with the purple. So this side right over here that I am drawing in purple, if you rotate it clockwise in the 90-degree direction, or a negative 90-degree rotation, well, it's going to, instead of being straight horizontal, it's going to be straight vertical. So it's going to overlap with what we had already drawn. And how long is it? Well, right now it goes from x equals -5 to x equals 4. So it's 9 long, and you can count that. 1, 2, 3, 4, 5, 6, 7, 8, 9. Or you could say it's 2 longer than what we had already drawn. So let's see, if you start at y equals -2 and you add 9, you're going to get to y equals 7. So this is going to go all the way like this. And then let's see, this side forms a right angle with it. So so it's going to go like this. It's going to be a right angle. And how long is this? It's 1, 2, 3, 4, 5 units long. So now we're going to go 1, 2, 3, 4, 5 units in that direction. And just like that, we get to our A prime. We get to our A prime. And we could draw the hypotenuse of this triangle. So let me see if I can draw it. So press, okay, I want to draw the straight line. All right, it's going to look like that. So we know where the image of point M is after the rotation. We know where the image of point A is after rotation. And we see how these triangles we've constructed, we've just rotated them. We've just rotated them 90 degrees in the clockwise direction. Now we just have to do this for point S. And then we have the 3 points for our image. So point S, once again, we can construct a right triangle. Let's do that. So hypotenuse will connect point S to our center of rotation. And I could do this several ways. Let me think about the best way to do it. Well, let me construct this right triangle. So it looks like this. And then it looks like this. So this top side right over here, if I were to rotate it negative 90 degrees, or 90 degrees in the clockwise direction, where does that put us? Well, once again, it's going to put us straight up and down. And this length it goes from x equals -3 to x equals 4. So it's 7 long. So it gets us to this point right over here. Now this side, let me be careful when I just say this. Let me do it in a different color. This side right over here forms a right angle. And so and if you see when you go from here, you go down. So here you're going to go left. And you see that it's 3 long. So it's 3 long. This is a right angle right over here. And then that gets us to our S prime. That gets us to our S prime. We can now draw the hypotenuse. So notice this whole kind of crazy complex that we have drawn of these different triangles, I've just rotated the whole thing by negative 90 degrees. That this triangle that we had just made, when you rotate it, it maps to that one right over there. But now we have in our image our S prime, our A prime, and our M prime, and we can connect them. So it will look like this. So let's just connect them. Connect the dots. So that, and that. And so you see, you might have lost our original triangle. I'm just going to shade it in so you can see it clearer. Although what we really care about is mapping the points. Actually, I don't want you to think that we're mapping everything in between. We're just mapping the points that define the triangle. So our original triangle that we cared about was this thing that I'm going to draw really bold. It was this thing that I'm going to draw really, really, really bold. And you rotate it by negative 90 degrees, which is equivalent to positive 270. You could have rotated it positive 270. You could have rotated it positive 270 to get to this other one right over here. But it maps to this. This is its image. Now we just have to go back onto the exercise. Now we have to go back onto the exercise and put it in. So let's remember these points. We have the point 8, 5. So we have the point 8, 5 in our image. We have the point 9, 7. 9, 7. And we have the point. And we have the point 1, 5. So we have the point 1, 5. And now I just have to finish it by going to this point again. And we're all done. We've rotated it by 270 degrees, which is equivalent to a negative 90-degree rotation. We can check that we indeed got it right.